Right, ladies and gentlemen, once again, I want to welcome all of you to the Valley of the Shadows of Analytics for Finance. Some will call it data science for finance. Some will call it artificial intelligence and machine learning for finance. Okay. Whichever way you call it, is an application of machine learning models, AI models, towards finance, towards financial analysis. We are looking at a second part of the time value of money. Specifically, we're going to look at annuity and we're going to look at perpetuity. These two are the focus of today: annuity and perpetuity. All right, so let's begin. And the first thing I want to find out is, what is an annuity? What is an annuity? Annuity. I want to take this slow because I understand not all of you two have done finance. So I'm trying to educate you on finance, whilst at the same time educate you on how to do machine learning, apply to it. An annuity is a financial instrument, okay, where you make a particular amount of regular payments over a period of time. So you're going to make regular payments. Let's say every month you're going to be paying a certain amount. As to whether it is at the beginning of the month or it is at the end of the month is a whole different ballgame. That would take us to two kinds of an annuity. But you're going to be making that regular payment, fixed payment. If it is quarterly, it's going to be happening every quarter. If it is annually, it's going to be happening every year. And if it is monthly, it's going to be happening 12 times in the year. Okay. So that is what we mean by an annuity. It carries the idea of annual. Now, you can see from the pictures also that it grows. Okay. Now, where are some of the examples of an annuity? Okay. Now, I've not given you the thing, but let me see whether you can remember. Who can give me an example of an annuity? Okay. Richmond, give me an example of an annuity, a real life example of an annuity. Yes, go ahead.
Salary.
Salary. Salary. Okay. Now remember that this is something you are giving, you are paying. So normally salary is like being paid to you. Okay. But we're talking about something that you are paying to someone. So what example? Regular fixed payment, generally. Linda.
Doc, I think SNIT payment.
SNIT pension payment. Fantastic.
Yeah.
That is an example of an annuity. What else? Set. Everybody should think about one example. Set.
I can also say if I have a running investment and I contribute monthly.
You got to be specific with what kind of running investment you're talking about here. Everything is more or less like an investment. They have names.
Okay, let me say child education fund.
Good. So you have child education trust fund where you make a regular payment. Fantastic. What another example do you have in mind? What other example do you have in mind? Seth, Joseph, Hubert. Come on.
Provident fund. So mortgages.
Mortgage, fantastic. Mortgage, okay. Mortgage. What kind of mortgage here? You got to be specific. There are quite a number of. Which kind of mortgage are you talking about?
So the monthly ones that you have to
Which
do.
one? Mortgage for what?
Come again, sir.
Mortgage means a lot. What kind of mortgage are you looking at here?
Oh, housing mortgage.
So you're talking about house mortgage. Okay.
Yeah.
You're talking about mortgage for the house. Some people do for the land. Some people do for the car. Okay? They call it car loan.
Yes, sir.
Like that. What other example do you have in mind that we haven't spoken about? Rent. Remember, your rent is like an annuity. Every month you're paying the rent, or every year you pay the rent. It's an annuity. Okay? It's an annuity. So that's a typical example of an annuity. Pension payment. Okay, your pension. Okay, it is an annuity. Okay, amortized loans. In fact, even bond payment. Okay, is all examples of an annuity. Okay, now listen, guys. There are two kinds of an annuity. The first one is ordinary annuity. You're going to calculate it very soon. And the second one is an annuity due. Ordinary annuity, or sometimes it's called annuity immediate. Annuity immediate. And then annuity due. What is the difference? What is the difference between ordinary annuity or annuity immediate and annuity due? Very quickly, very, very quickly. Let's go to Joseph. Joseph, are you there? Everybody should be alert. I'll call you all the time. Okay, all the time. Joseph.
Hello, Doc.
Go ahead.
Yes, Doc.
Go ahead. You say yes, Doc. Focus. Some of you are not focusing. You are not paying attention. You are not paying attention, Linda. You are not paying attention, Linda. Pay attention. Focus. Look at me.
No, Doc, your line is breaking, so I think I'm having internet challenges.
It's not my line. It's not my line that is breaking. It's your internet. You can't hear me well. Okay. So let's go to Hubert. Hubert, what's the difference?
Okay, so let me try. So an annuity immediate, you are making the payment over a fixed period of time, usually at the end of each period.
Mm-hmm.
Yeah, whilst the annuity due is usually at the start of the period. You make it at
Give
the
me an
start
example of each one.
Okay, an example. So for annuity due, annuity immediate, this will be hard.
Guys, you got to pay attention because I'm going to give you a question and you have to determine based on the question whether it's an annuity immediate.
So it could be a loan amount.
Mm-hmm.
Yeah, it could be a loan amount that you are to pay at the beginning of, let's say, each month.
And then the other example?
For the annuity end, you'd have to pay the loan at the end of the month or the
You
end
already
of the
said
period.
that. I'm asking you for example. Give me real life examples. Okay, an example is your school fees. Your school fees that you pay it every quarter or every year or every month. That is an example of an annuity due because you pay at the start of the period. So you pay before you start the thing, like rent. You pay before you use the house. You don't pay at the end of the month. You pay at the start of the month. So that is an annuity due. But annuity immediate, you pay at the end. Now, if you look at their terminologies, it might look like they should be the opposite. Immediate is rather at the end of the month. And then the due is rather at the start of the month. So keep that in mind. All right. Now, what's the difference in calculation? The difference is that the present value of an annuity due, which is actually at the start of the month, is the present value of the ordinary annuity multiplied by the discount rate. Watch the calculation there. I'm going to give you an example right now. It is multiplied by the 1 plus R. Write it down. Write it down. You'll forget some of these things. There's a deliberate reason why I'm not giving you the note. I want you to write things down and pay fullest attention, because within this short period, I'm yours. I'm yours. So pay all the attention to me. Then when you finish, you know you've done your part. All right. So this is a formula for that. So, but let's pick each one of them one by one. Let's look at the present value of the ordinary annuity. How is it before you multiply that by 1 plus the discount rate, or 1 plus the interest rate, and then you can now find the annuity due. Okay, let's take an example. Okay, so this is a real life situational example. Okay, we have two sort of questions here. Assume that you rent an apartment. It is your house. You rent that apartment, and you will be receiving a uniform payment of $100 at the end of each year over 5 years. What will be the amount? What will be the present value of that? Now, what is in this question that tells you that it is about an annuity? Who can tell me? What is in the question here? What keyword is here that tells you that this is about annuity? Richmond.
Because of the regular payment.
There is no word here called regular.
Is a uniform.
Yes. So you see, I was asking you of the word, and that word is uniform. So that gives you the idea that this is an annuity question. Okay. Now, we are going to go to your Jupyter notebook. So please go to your Jupyter notebook. And then we are going to solve this together. This is your Jupyter notebook. Let me show you. So I've given you this Jupyter notebook that you all have here. And this is the first one. So when it comes to the first one, I'm solving that for you. Subsequent ones, I will not solve it for you. You would have to solve it yourself. Okay. Now, the first thing you want to notice that the present value or the future value of a question, there is a NumPy financials that you can use to do all these calculations, which is already in Python. It can do it all for you. And it is NPF. That is the name, NPF. Now, regarding this NPF, anytime you want some help about it, you just type NPF and you will always get something that you want to know about it. So in this very example, once you type help npf.pv, okay, it will give you the help that you need. Once you run this, watch it. Okay. Watch it. Okay. Now, for you to be able to run it, you must have defined the NumPy financials already. Okay. Now, if you have not defined it and you ask for the help, you might not get it. So let's quickly do that. So put it here, and you do that also with yours and run it now. So you import the NumPy financials as NPF. Okay. It's already inside the memory of Python. So once you import it, it gets there. So I'm now imported it and I'm now running the help again. So you can now see that the help is now showing. Okay. Remember to type this nicely. You have it also in your second command. So all I did is I came down here and then you copy the second command. Okay. It's somewhere, but if you can't find it, that's it here. Okay. Just type this, import NumPy _ financial, and then you can now get a help. Guys, it will tell you all that you need to know about this library. Okay, for example, if you want to calculate the present value, you have to know all of the following. You have to know, if you want a PV, you have to know the rate. You have to know the number of periods. You have to know the regular payment. You have to know the fixed, the future value. And then you have to know everything here has been defined. For example, you have to know whether it's at the beginning, okay, or it's at the end. And the other information that you need to understand everything, how the whole thing will be calculated, and then it will be finally given to you. It is all here. An example of whether you are using NumPy or NumPy Financials is all there. He even has a particular example on how to calculate here. So this one, it says what is the present value? What is the initial investment of an investment that needs a total of 15,692? And then after 10 years of saving 100 every month, assume the interest rate is 5% annually compounded monthly. So it's giving you an example for you to work it out. And then you can work out through all of these examples. Anyway, so now let's go back to our own. Our own is this. I'm just going to go back so that you can see the question because it's quite long. So I'm going to put a hash symbol here so that when I run it, the help will not come again because the help is quite long. So the first thing you got to note is you got to know the formula for the present value. I'm going to go back to the slides and show you something interesting before we come back to this. So if you decide to express, so remember, every month or every other year, you are paying $100 at the end of each year for 5 years. So by the 5 years, ideally, we are talking about 500. Sorry, you are going to be receiving this amount of money from your rent. So your tenant is going to be paying you 100. But you want to know the value of that money today. In the future, it is going to be 500. You know that. But what is the value of that? Well, you calculate the present value of each of the 100, as you can see here. Okay, this is hand calculation first. You calculate the present value of that. Now, from last time we met, you would remember that the present value is given as the future value divided by 1 plus the rate. Okay, 1 plus the discount rate. Now here, the discount rate is 10%. It's 10%. So the denominator is going to be 1 plus 0.1, which is 1.1. Now, if the year is only 1 year, it is raised to the power 1, because so that will be the T, the time period. If we are in the second year, the year will be raised to the power, the denominator will be raised to the power 2. If it is 5 years, it will be raised to the power 3. And then you calculate that, and then you will now get the value of all the accumulated amount today. If you do that, you are going to get this amount, okay, which is 379. So what does this mean? What this means is that if I were to give you 100, I'm your tenant, $100 every year for the next 5 years, ideally, you're going to be getting, an amount of money in the future. But today, okay, what is the value of that money? The value of that money is 378.1. So this is the formula for the present value of this annuity. Okay. Now, there's another way of writing the formula, but it's the same thing. Okay. You write the formula as the payment multiplying 1 minus 1 plus the interest rate raised to the power negative time period, okay, divided by the interest rate. It's the same thing. Okay. And that is how you work the present value. Another way of writing the formula is this. Now look at the second one. Okay. This one is an interesting way of writing the formula, okay, because this division sign is what we had here. That is similar to. So here they were using I to represent the interest rate, and here we are using R to represent the interest rate. It's the same thing. Okay. So this P is the payment, that regular payment that you are making. And the N will be changing as you move across each other year. Okay, so you should learn how to calculate present value. Okay, so the first year, the person is paying $100 to you, but its present value is 90. The second year, the person is paying 100, but you want to know that 100 today, it is 82. Okay, and then every other year you're going to get. So the further away the year is going, the lower the present value of that amount. Okay, so now let's go to our Jupyter notebook, and let's see how to calculate this. Now, I'm doing this for you, but subsequent ones you're going to do it yourself. And timing is everything. I'm going to be timing you. This is how your exam is also going to look like. So the first thing is you should write the formula for the present value. What is the present value formula? Now remember, NumPy will teach you how to do the calculation. Now, if you could remember the help, okay, let me just run the help now. Okay, this is how the formula looks like here. I'm going to copy this formula and show you like the way you got to structure something like this question. So I'm just going to create a sheet. Oh, come on. I'm going to create a cell here. Okay, so I'll create one cell here. And then in this cell, I'll put this whole thing in there. Now watch this. So you got to know the present value you are going to calculate. So let's put a formula. So let's put the formula here, call it PV, capital PV equal to. Okay. And then bring your NPF dot, your present value. That's what you're going to do. And then remember the formula. The formula said at the end that you got to multiply it. Okay. Remember the formula carefully. You got to multiply it by 1 plus something, or 1 times something. You got to take each one of them. So let's pick the first one. What is the rate? The rate that you have, put it down here. Who can tell me the rate in this question? What was the rate? Do you remember the rate? It says 10%. Okay, 10%. So what you are going to do is that you're going to write equal to that 10%. You're going to give me the answer. Then the number of period. What was the number of period?
5 years.
5 years. So you put your 5 years there. Then the payment. What was the payment? What was the payment? How much were you collecting from the rent every month? The person is supposed to pay you that rent every month. How much was it?
At least $100.
It was $100. Now you write that $100, but what do you put there? What do you write there? That $100, okay? That $100 is it a negative value or is a positive value?
I think positive.
That $100 from the person. As far as the person is concerned, what is that $100 to him?
It's a payment.
Yes, a payment. So is it a payment leaving the person or coming to the person? That's my question.
Leaving the person.
Okay, so the value will be negative. Okay. Now let's go to the future value. Okay. The future value here was not the focus. There was no calculation for the future value. So the future value will still be 0. And then the when, okay, the when we'll leave it as, end. as it is because we don't have any win. So you put all these values there, and then you run your command, okay? And then after that, you print your PV. You print your PV like that, and once you print your PV, you can now get the result that you want. Now your PV has to be positive because you've already applied the negative to the payment, the regular payment. Now, if you can remember last time, we were not touching the payment for most of the calculations. At this time, we are touching the payment because this is a regular payment. What did you get? What answer did you get? Did you run? Did you get an error? Correct your answer to 2 decimal place. Now, if you want to connect your answer to 2 decimal place, you have to just do this. Bring round, bring the bracket and bring round. And then after this, do comma and write 2 like this. And then you'll get your answer in 2 decimal places. I'm not doing this, but I want one of you to tell me your answer. If you face the challenge too, I want somebody to tell me. Let me see the people that are here. Hubert, are you here? I need an answer from you. Linda.
Please.
Richmond.
Please, I had 379.0.
37.0 something. That's what he said.
No, 379.
Okay. So if you do that very carefully, okay, you are going to get. Now, normally, some people will do it one by one like this. It's not a good way. It's not fast. Okay, it's not fast. So the first one, you use this result, and then you run that result, and you're going to get a very, very, very beautiful answer. So if I were to calculate this, how would you have done it? I would have done it very, very simple like this. Okay, you put in everything here. So you first import your NumPy, you first write your PV and PV, put your discount rate there, put your number of period, put your payment, remember to negate it, have your future value, and then the when is end, print and round it to 2 decimal places and do boom. You get 378.08, 79.08. And that is your present value. What does this mean? See, sometimes it's one thing calculating the present value, is another thing understanding the calculation. Okay. What does it mean? It means that if you want to be able to get that money, okay, its present value is going to be $379.08. Okay, now I'm going to give you one to work it for me here. Okay. You have just 2 minutes to do that. I want to see the smartest person in this room. I want to see the smartest person in this room. So your business has won a contract that will pay 500,000 cedis at the end of each year for the next 5 years. Watch it. You have decided to sell this contract to a business partner. Okay. Assuming that the interest rate is 18%. What will be an agreeable price for this contract? Now, first thing is, what kind of financial calculation is this? Is this present value or future value or payment? Now remember that given the formula here, given the present value formula, you could be asked to always calculate any of them. You could be asked to find the interest rate. You could be asked to find the number of period. It's all change of subject here. You could be asked to find the payment. You could be asked to find the future value. Okay, so you got to know from the question which one you are calculating. And in this very example, which one are you calculating? Who can first tell me? What are we looking for? What are we looking for? Okay, looking at the previous one, which of these elements are we looking for? Who's talking? Yeah, Richmond.
Please, we are looking for the present value.
Go. What is the word there that tells you that we are actually looking for the present value. What word is there?
The agreeable price.
Good. So you want to know the agreeable price for this contract today. Okay? Because everything tells you that, you know, the contract is going to pay $500 at the end of each year for the next 5 years. So what is the price or the value today? That's what gives you the clue. All right. So you use the formula and come out with a result. And let me see. If you have a question in this process, always remember to ask. Okay? That's the only way you learn these things. Who is done? Put speed into these words. Who is bold? Say that again.
1,560,563.
Just tell me 1 point something million. That's all.
Okay. So 1.5 million.
1.5 million.
Yeah.
Okay. Or 1.5 what million? Add the next number.
So it's 156.
Good. 1.56 million. So is that what the rest of you had? Who had the same thing? Who had a different one?
I did. I had the same thing.
Good.
Doc, I did.
Yo, Asawada. So now, what happens is, now you know that this was about that. So the rate was 0.18. You can see it here. The number of periods was this. If you said that you did that, do the next one well and let's see. And then you have the value. Now here, I negated this because again, remember, you are paying, okay? You are paying, so it's leaving. That's why the negation there. It doesn't change the result. The future value is still 0. And now the present value is there. So once you run this command, remember to always bring the import, okay? Because sometimes some people don't write it because they think that they've written it at the top. But when you get used to writing these things, it helps you. So once you run it, you get this amount, all right, to 2 decimal places. Learn how to write things in 2 decimal places.
So it looks like I am getting error. I don't know where it's coming from.
Well, check it carefully. Check it.
It
NPF.
says my PVA is not defined.
Which PV? Is it this one here? Or the small?
I think the big letter PVA is not defined.
Okay.
Yeah, that's what I'm getting.
Did you type print around this?
Yes, sir. Print round
Did you do this?
PVA.
A equal to?
Oh, it's PVA up there, not PV. Okay, sir. I
No,
think
it
I've
doesn't
seen
matter.
where.
It doesn't matter. That's the way I define it. You use PV here, right?
Okay, so I should just define
Did
what
you
I
use
used.
PV
Okay.
here? Did you use PV?
Yes, sir. I used
And
PV.
you also use PV here, right?
Yes, sir.
It doesn't matter. That should work. So the issue is not because I use PV, the present value of an annuity, PVA. But it doesn't matter whether you use PV there. What matters is, did you have this import there?
Yes, sir. So I think it's rectified now. I'm getting result.
Okay, but you should know why you weren't getting results. That's the most important thing.
Yes, sir.
What is
So
the
I think
answer?
another thing is that I'm getting a negative result.
But you know why? Because you didn't put a negative value here under the PMT, the payment. I told you that since it's leaving you, you have to put a negative value.
Oh, right. Okay, sir.
500,000.
Yes, sir. Great. Thank you, sir. All sorted.
All right. Let's go to the next thing. So what you've just done is that you've calculated the present value of an annuity. Now, I told the examples of an annuity is amortizing of loans, loan amortization. Let's look at a situation that will require that. Under what circumstances that loan amortization giving a present value of an annuity? Let's look at this. So this is a question that says that how you repay the loan, the principal over time. Okay. And when you repay the loan over time, the one you took to finance your house or the money you took to finance your MSc, that is a typical example of amortization. So amortization is how you repay a loan you have taken. That is loan amortization. The way and manner you go about repaying the loan that you took. That's what we call amortization. So let's say that you took some $10,000 from a bank, okay, for 5 years. You told the bank that you are taking that 10,000 and it's a loan the bank has given you. Okay. Now, with this loan, you are going to pay for a fixed annual payment. So every single year, you're going to make a payment at the end of each year over the next 5 years. The annual interest rate on the loan is 8%. What must your annual payment be? So what is this question really asking you? First of all, is it the present value of an annuity due? Or is the present value of an annuity immediate? Who can tell me that? Is it the due or is it immediate? Let me see that first. Is it the due or is it immediate?
So I think it's immediate.
It is immediate. Why?
Yes, sir. Because it stays each year that the payment will be at the end of each year.
Fantastic. You are learning. Excellent. Now, second question is, which of these are you looking to find? Is it the rate? Is it the number of period? Is it the PMT? Is it the FV or it is a PV?
The PMT.
Is that what?
The PMT.
Good. How did you know that?
Because he said, what must your annual payment be?
Good. So in this formula, how is the formula going to change? Who can guess? Since we are not actually calculating the PV, but we are calculating the PMT, which is annual payment. How is this formula going to change? Any idea? Okay, so the first thing is, I remember, like I told you, this PVA is something I coined myself. This time I will not coin that word because I'm not going to calculate the present value of this annuity. Oh, first of all, you should know that this is an annuity because there's a regular payment of, amount of money, because what must your payment be? That word means that the payment must be regular. All right. So you can use a different word instead of present value of an annuity. It's going to be the payment of an annuity. It's going to be that PMT you're going to be calculating. Okay. It's not going to be the PV, the present value of an annuity, but it's going to be the PMT, the annual payment that you're going to be making. So instead of saying PVA, I would say something like, of course, you got to do your import as always. Okay. So you copy and paste, do your import, And then you can say that the payment, PMT, of an annuity, you can bring A, or just say payment, equal to. But what will also change is that the PV, NPF.PV should not be used. What do you think should be used? Instead of the NPF.PV, what do you think should be used?
The PMT.
NPF.PMT.
Correct. Now I want you to proceed. Proceed with that. And then find out your answer. And let me see. You are right in what you said. The question now, and remember, whatever you have chosen as the dot PV or dot PMT, that will not be inside the bracket again. So this time, what is not there should be there. What was there should not be there. So for example, since there was PV here as the dot PV, you can see that there was no PV in here. There was no PV in the curly bracket, in the bracket, okay? Because that is what we are calculating. So whatever you are calculating will not be part of the element in the bracket. So on the basis of this, calculate, and let me see, calculate the annual payment. Who is that? Who is that? Who can walk me through? Yeah, Richmond, go. What will it be? Just say it once I type it.
2,504.56.
Now what? You had what?
2,504.56.
Who also had a different answer or the same answer?
Doc, I had the same answer.
You had the same answer.
Yes,
Good. Was it positive or negative?
it was positive.
It's supposed to be negative. I know I didn't say it. Why do you think it's supposed to be negative? You can tell me. This is it. Why do you think it's supposed to be negative? This is it. Now, let me tell you why. Because, first of all, you have the PMT. For those of you who don't know, the interest rate is 8%, so that is 0.08. The number of period is still 5 now. The present value is supposed to be positive because remember, okay, we said that the present value, all these present value that we're calculating above, they were all positive. So the present value will be positive. As for the feature value and the duration, we don't have that. And so if you print out the payment will be negative. Why? Because remember, you want to know the amount you got to pay every single year. And that means that the amount is leaving you. It is being taken out of your money. So it's like an expenditure. And because it's an expenditure, the value will be negative. Okay. That's it. And then you run that is 2,504.56. That is what we mean by the present value or the payment of an ordinary annuity. Now, there are some few things you want to take notes here so far. Number one, everything we've done is ordinary annuity. Why? Because you are making the payment at the end, at the end, at the end. Ordinary annuities, are annuities where the payments are at the end. And this is a typical example of an amortized loan. But some payments are made at the start of the time period, not at the end. And they are the annuity dues. And we've said that an example is a school fees. So what we are going to do now is, you see, when you have an exam situation, you don't know which one you are actually dealing with. And by the way, this is so practical. When you are in a financial institution, you don't need to go through all the wahala. Once you know these things, all you got to do is to plug in the values into the command, and then you know the results. So somebody comes to you, a client comes to you and tells you that, okay, I have this amount of money, I'll be paying this amount of money. Can you tell me? Straight on, you have the NumPy financials to do your work. So we're going to assume payments that are made at the start, not at the end again. And to do that, ladies and gentlemen, please pay attention. To do that, we will no longer be leaving this part, the when. We will not leave it at end. You remember how the end meant when it was 0, so you don't write anything. Okay, we'll use that when feature in the present value and then the future value calculations. We'll use that when. In case you forgot it, let's just go back here so that you know what that when actually stands for. It's here. Okay. It says that at the beginning or at the end. And all this while we are dealing with at the end. So we're using 0 or end. We're just writing the word end for the period. Okay. But this time, because it's at the end, so it's like time periods have been converted. This is a dummy variable. And so now that is going to be at the start, the value or begin must be indicated. And because it must be indicated, watch the question carefully so that you know how you indicate the value. Let's take an example. Okay. This is an example question. What does the question say? You plan to receive 1,000 at the start of each month, at the start of each year for the next 5 years. So you're going to be getting $1,000 at the beginning of every year for the next 5 years. The year you have decided to marry. So you are packing the things. If the interest rate is 8% per annum, what amount should you invest today so that at the beginning of every year, you know you are guaranteed your 1,000, so that in 5 years' time, you can have a wonderful nuptial ceremony. Question I want you to do now is that I want you to think using the same principle now. Calculate what they are asking you to calculate. You have 3 minutes. If you have a question, you can ask me. Calculator. How are you going to address this question? First of all, what are you being asked to calculate? Who can tell us? Is this ordinary annuity or annuity due? Is it ordinary annuity or annuity due? Anybody?
Sir, this is ordinary annuity.
No. Richmond?
It's an annuity due.
There are only 2 of them. So explain why you think it's an annuity due.
Because it's at the beginning. The payment is made at the beginning of each year.
Exactly. It was explicit. You see, I told you that some of them will forget. I said, if you are not paying slight attention, you forget. And here it is. He forgot. He forgot completely. So first of all, it's an annuity due that you're calculating. Nothing changes. Nothing changes. The only thing is, instead of saying that, annuity, immediate, now it's an annuity due. So what are we going to change? How is it going to change? Well, let me show you how you calculate what is the formula for an annuity due. Okay, it's not the same as the formula for the ordinary annuity. First of all, look at the annuity due, the connection between the annuity due and the ordinary annuity. It is the ordinary annuity. But once you have finished calculating this ordinary annuity, you multiply that by 1 plus the interest rate. So first of all, calculate your usual ordinary annuity. Then the annuity due is the ordinary one multiplied by 1 plus that. Whether it is a present value you are calculating or the future value you are calculating is the same approach. So on the basis of this, copy your formula, calculate, and then do the time. Do you know how to write the times in Python? If you want to write that times, do you know how to write it? Who is smart among us here to tell us? Which of you is smart to know? Okay, if you want to calculate the times, whatever you do star star. So you do star 2. Okay, and then you multiply it by the 1 plus whatever interest rate. Let's say the interest rate is 8%, is 0.08. So whatever you have here, which is multiplying whatever is on the right, whatever you have here is the present value of an ordinary annuity. Whatever the one we've done before, and then you now multiply it by. So that is how you do it. So do that and let me know your answer. Who is done? Who is ready? Who is ready? The ladies, I've not heard from any one of you. Are you here at all? The ladies, are they here?
Doc, we are here.
Oh, don't disappoint me. Don't disappoint me. You are disappointing me. You should talk. So the first thing you're going to do is to write your import function. So you can see that I've done that first. Then you write your formula. What was the formula? What formula have you written so far? Who can tell me his or her formula? So let's say that this thing is called PV of annuity due. So I will do PV due. Okay. Let's say we do PV due. Then you write equal to. Okay. And then you write the NPF. And what are we finding? Are we finding the payment, the present value, or the future value, or the number of periods? What are we finding? Are we finding the present?
The present value.
The present value. What gives you the clue that we are finding the present value?
And so the question stated that what
Which word?
amount
One
should
word.
you today?
Today. Excellent. That's it. Today. That's a value today. Fantastic. So what have you gotten? You write the interest rate equals to 0.08, comma. Then you write your number of period, which is NPE, equal to, what was the NPE? 5, right? That's 5 years. Okay. Then you write your payment. The payment is always PMT, which is equal to 1,000, but because it's leaving you, you write negative 1,000, comma. Then your next thing to do is to write your future value, okay, and set it to 0 because this time he's not asking you to find that. And it's also not giving you the future value. Yes, Richmond.
This I'm a little bit confused with the why you made it minus tau, because in the question it says you plan to receive, but you are saying it's leaving us. So I thought that it would be positive. I don't know.
No. Very good question. So he says that you want to receive at the beginning of each year. So let's say that you're not getting the money today. You're going to get the money at the beginning of 2026.
Okay.
And 2027, you're going to get that money. Okay. Not that you are receiving it now, but you're going to get that money already. Now, the question is, what amount should you invest today? What amount should you invest today? Now, even though you're going to get that money, whatever amount you invest today, it is going out, isn't it? Whatever amount you receive today, is it not going out?
Yes, sir.
It's going out. And so if it is going out, it means that eventually what will happen? You will get that money back. But as it stands now, it is the same money that is going. It's the same money that is leaving you. So at the end of that time, even though that money is kind of back to you at the beginning of the year, even though the money is back to you, it is like it left you first. Because it's kind of money that is leaving you first, it is still going to be negative. Okay? It won't change the result, but that is how it is. And let me give you a clue. PMT are mostly negative. Just so you know, PV, when it is in the bracket, the PV is mostly negative. When the PMT is in the bracket, it is also mostly negative. When the feature value is in the bracket, it is positive, mostly. Just so you know. Okay, so the PMT is negative from that principle. All right. So you do that, the feature value is 0, and then what about the when? The when is going to be end, right? So you type end. And this will give you, if you were to calculate it, this will give you, ordinarily, this will give you the present value of ordinary annuity.
Hello.
Yeah, go ahead.
Hello, Doc. I have a question. Wanted to understand why we are using end and not begin.
And not
Begin.
Yes. Your question is what?
So I'm asking why we are using end and not begin.
We haven't come to that because we're still dealing with annual. Okay, because we're still dealing with annual payment. You see, you want to understand what the when means. When the when means, it doesn't, it's, first of all, it's a dummy. And we know exactly when we are going to get the money. We know exactly when we are going to get the money. And because we know that exactly when we are going to get the money, we are not manipulating that end. We are not manipulating that end. We are not changing any value of the end. And like we said before, if you understand the definition of the end, okay, the end is a dummy variable that you only, in fact, even if you are changing it, you are changing it by using the word end. It is what time of the period, and what time of the period has been given. In this case, it's 5 years. And so once you know the period that has been given, you don't change, you don't alter that end. It's not like, there must be a trick question that will help you to know the beginning and then not the beginning. At this stage, that money that you're going to receive that money at the beginning, but it's not going to happen now. You're going to receive the money at the beginning of the year. And so you're not touching that end still. It hasn't changed the end. Maybe your question will be, when will you touch the end? You will not touch the end. Okay, you will do that next time when we meet next time. But this time you will not. But again, it is about your understanding of what it is. It's understand. It's a dummy item. It's not a numerical value. And it's like, do you know or you don't know? I know. Okay, I know. 1. Okay, I don't know. 2. I don't know. 0. Okay, that is when you now touch. But now you know. And even if you don't know, it's still going to be I don't know or 0. So you're not changing the value of that, because again, it's not a metric variable. It's not a numeric variable. It's not a float variable. It's a string variable. And so it will not affect your judgment and the way you calculate it. All right. So that's why we are not changing that end value. So the future value is still remaining
please,
as it is.
a follow-up. Hello?
Yes.
Is a follow-up. So by your explanation, so does it mean that now if we are looking at uncertain period, so like something like a perpetuity, then that is when you change it, we touch the end?
Yes. But even that, there's an easier formula that you're going to use for that.
Okay. Sure.
All right. So once you get this whole thing is the present value of an ordinary annuity. So you multiply that, use your double star to multiply that by 1 plus the interest rate, which is 0.08. That's it. Okay. We run that, and then you do print. Now, in this print, what I want to do is I want to put it in a sentence. So I want to say that I want to put in a sentence that a print F, the present value of the annuity due. Okay, and I'm going to call it PV underscore due. And I'll put that in double quotation so that it becomes a sentence. So let's run that. And then you get 7,771. Is there anybody who had that? Oh, sorry, I made a typo.
Yes, please. I have it.
Yeah. Let me see. The future value is what? It's 0. The present value, the time period is 5. Oh, times, sorry. It's supposed to be times, not to the power. It's supposed to be times. I made a typo. It's supposed to be times, not to the power. So when you run that, you get 4,302. Is that what you had? You're multiplying it.
Yes, please. 4,312.
Okay. Very good. Now, let me ask a couple. Rabin, are you here? Rabin, you have not been serious in my class at all.
Sir, please, I'm here.
Yeah, and I know you are here, but I'm saying you haven't been serious in my class at all. You don't talk, you don't participate, you don't do anything until I call you.
Sir, Pastor, I even had a question for you afterwards. I wanted you to
Oh,
finish.
afterwards, whilst your colleagues are asking the question.
No, like when you run. No.
But your colleague was asking me the question even when I was talking.
Because we're running this. Yes.
I've told you to interrupt me when I'm talking. Interrupt me. So don't say that I was going to ask you a question. You were not going to ask. Ask your question. Just go ahead and ask your question.
Actually. Okay. So, please, the discussion about the when, the end, using the end and when we use the begin, right? I just wanted to confirm because I just tried
the point
something
is that you
on
didn't
the
understand
side.
it, isn't it?
Oh, no, I just wanted to try something on the side, right? When you use the when as begin,
We'll get there.
right?
I'll show you.
Pardon?
When we get there, I'll show you.
Okay.
They're asking by first question.
Okay.
Yes, Richmond.
Look, I've realized that when you change the when to begin, it will give you the answer we are getting now, without multiplying the whole answer by the 1 plus 1 plus R, the 1 plus the rate.
Yes, if you don't use that interest discount.
Yes, please.
Yes.
So if you just change the when to begin, it will give you the
Which would now, yes, which will now confuse you. So let me show you something. If you look at this formula here, do you see the screen?
Yes, sir.
Okay. If you use that, you will get the same answer as this, but it will confuse you because you will not understand this formula, because this formula is not inside a Python. So if you don't take care, inside a Python, you might think that the present value of an annuity due is going to be the same as the present value of an ordinary annuity. I don't know if you understand my point I'm saying.
Please, I'll get you.
Yeah. And I've seen that people get confused all the time. So normally, but it's very good you spotted it. So normally, I don't want to bring that up because they will always think that is the same thing. So when you give them a question related to one, they will not know when to use that one. And when you give them the other one, and you ask that same question in a different way, they will still now not know that they don't have to use that to change it. So let me go back here. But you should know that this very thing is an important element because it is helping you to know the time duration in there. If you use this, let me go to the one you used. If you use this and you cut off all of this and you use the begin, and you get the same answer. If you don't take care, you will still think you are calculating the present value of an ordinary annuity. But actually, what you are doing is that you are calculating the present value of an annuity due. Okay. And also the formula that you get that formula, which carries the idea that you have 1 plus the interest rate. So that gives you the knowledge that it is the present value of an annuity due, which is the present value of an ordinary annuity multiplied by the 1 plus the interest rate. But if you understand it the way you understand it, it's fine. But I'm telling you, even by now, me talking about it now, somebody might be slightly even confused. You know, you yourself, when you spoke it and now I'm explaining it, your brain is doing oh, you are fine.
Yes, sir, we are here.
Okay. So that's it. So you can still use this to calculate the present value inside the Python, which means that the 1 plus the interest rate has already been taken care of by the begin, which is the 1. But other than that, you maintain your end, and then you bring this, okay, and you know that you are actually calculating the present value of an annuity. So just so you know, whichever one that is fine with you, but you should know the principle. If you are hand computing, you should still be able to know. All right. So that is how you compute the present value of an annuity due and then the present value of an ordinary annuity. Now I'm going to give you a question. You don't know which one it is. Okay. This question I'm about to give you, you actually don't know exactly which one you are calculating. You don't know. The question is, your job is to find out which one you're calculating. So let me show you. And this time I'll show you in the slide so that you can work it in your PowerPoint, in your Jupyter notebook. So you plan to receive $1,000. Oh no, not this one. So the B part of that question, and again, you can see it in your own. The B part of that question. Okay. Oh, by the way, you should know that there's a second approach, which I've given you. When you run the second approach, you see that you get the same thing. Okay. That second approach, you define the formula. Sometimes you don't need to use the NumPy financial, but you just define the formula. So that second approach is there. You can check it on your own. But let's go to where you don't receive 1,000, but you rather receive 2,000 every year at the beginning of each year for 4 years. When the discount rate, I want you to calculate the present value of that. This one, this second one here. I want you to calculate the present value, knowing the previous question. And by the way, you can copy and paste. Godwell, which other people joined the call?
Doc.
Yeah, I saw some 2 other people. Who's been able to calculate this one? Let me move faster, okay?
Thank you. Thank you.
So when you calculate this, it's fairly simple by the previous one, okay? Just have to, you can just copy this whole thing, bring that here, and just paste it. Remember, you are just changing this one to 2,000. And then you can, the interest rate is still, this time 10%. So you change this one to 0.10. And then you change the 2,000. Everything else is the same. You run this, you get this value. Okay. Or you can decide to, like your colleague was asking, and I told him the possible confusion. You can remove this whole times, then the begin, to indicate that you are doing an annuity due, and then you run this, you get the same thing. Now, take note.
Doc, please, you didn't update the period and then the rate.
Oh, sorry, the period was 4 years.
Right.
So you get 7,154.
No, and the rate is 10%.
It's good. Actually, somebody will say, I was trying to see whether you can. Actually, when you come here, I have it all in the slides, but I want you to see, I want to be sure whether you are following me. That's all. So if you look here in the slides, you see that. Okay. So that is rate of 10%. That is there. Number of period is 4. Okay. The payment is still negative 2,000. And then you have this. All right. So that is how you do your calculation. If you do it well, you're going to get 6,973. Is that what you all had? Yeah.
Yes, please.
You should have that. Okay, good. Now, the C part of the question. Okay. Before we go to the C part of the question, I want you to know something about annuity due. It can grow. It can grow. You can read more about it, but this is the formula for finding an annuity due. Okay. The present value of an annuity due is given by the payment, okay, multiplied by this whole element in the bracket, multiplied by the 1 plus the interest rate. Now, a question will tell you the growth of an annuity due. And it comes with the nature of the changing of the timing, the period, you know, from year to weeks, or from year to months, or from year to quarters, and all of those things. So let's take a typical example. This is a typical example, okay? And I'm taking that from your Jupyter notebook that you have. It says that you will receive 1,005 every month, okay? You're going to receive 1,005 every month at the start of each month for 5 years. The annual interest rate is 9%. What is the present value? What is the present value? Now, what is this question requiring you to do? First of all, what shows that it is not an ordinary annuity? You can tell us. What shows is not an ordinary annuity?
Sir, because
The
the
word
money will be
beginning.
at the beginning of each month.
Again. Say that again.
Sir, because it will be received at the beginning of each month.
At the start of each month. Fantastic.
Yes.
Good. What else? So first of all, you have it at the beginning of each month. Now, how do you calculate it? Because now when you have your formula element, okay, so let's say that we are going to copy all of these. I'm just going to pick this and you will see, okay, what is going to change. Let me drop it here. What is going to change from here? Looking at the question. What is going to change?
Doc, I think we would have to divide the rate by 12 since
Good.
the money is
Why?
going to be received per month. Because the rate is annualized, the 9%, is said the annual discount rate is 9%. However, the money will be received per month on a monthly basis.
Fantastic. So what will change? The 8 will change to what? The 8 will change to 9 because we are dealing with 9%. And then you divide that 9% by what?
By 12.
By 12, okay? Because everything is in months. So you divide it by 12 in that regard. Okay.
Right.
Next.
The period would also have to be multiplied by 12.
The period will be multiplied by 12. That is correct. Because you are still dealing with months and no longer years. It is each month for 5 years. So you got to multiply it to that. What else?
Then we indicate
The 1,005 is in months. So what changes there? What changes here?
We only change the 1,000 to 1,005.
Good. And then what do you now do? I mean, there are two ways you can look at it. And that is where the guy who spoke about the begin and the end, you see why this thing sometimes. Remember, you're calculating the present value of an annuity. So what will you do here? What else will you change? Will you do? You do the one.
I think the rate, the 1 plus R. So the 0.08 would also have to be, the 0.08 would have to be divided by 12.
So you change this one to 1 plus 9% by 12. Right? Now remember, you're still keeping your end. You are still keeping your end. When you run this, okay, you're going to get 72,802. And this is the correct answer. Okay, so you are going to receive 1,005 every month at the beginning of each year for 5 years. Okay, the present value of that is 72,802. Now, the guy who was talking about the begin, if you use this begin approach, what will you get? How do I? Okay, this thing is not changing. If you use your begin approach, how will you do that? Is the guy still here? Forgotten who was talking there.
So I'm here.
If you use your begin, okay, if you take this your begin and you come here and you change this thing to begin, and then you wipe off this, right? You get the same thing.
Yes, sir.
Oh, sorry. I'm using a different thing. No. It's not this one. I'm in a different level. This is it. Okay. So when you pick that, let me create a new cell here. And you take this, because you're not supposed to. You get the same thing. But as long as you know that you are dealing with the present value of an annuity. The difficulty here, and I don't know which one of you spoke, the other guy who spoke. The difficulty here is for some people not knowing that this is annualized. And therefore, as a result of that, you have to multiply the period by 12 and divide the rate by 12. This is a key. This is a key. But once you recognize that, but the formula for doing that is what I showed you earlier there. Okay. Use that approach to do your calculation. Now, let me take you back here because we are getting to the end of this. So there are different ways of, once you have an understanding, it's just using Python to calculate these things. It's having an understanding of how these things work. Okay. Let's record the formula for the future value of an annuity. So this time is a future value, not the present value. And this is a typical example. Again, it's the same thing. You calculate the future value of ordinary annuity, okay, annuity immediate. Then you multiply that by the 1 plus the interest rate. So look at this. You will deposit 1,000 at the start. The fact that it's at the beginning means that it is a future value of each year for 5 years into an account that pays interest rate of 8%. What is the future value of this annuity due? So this one, the question has been clear. What is the future value of this annuity due? Let's go back to the code. So this is the question that is here. What is the future value of this annuity due? Okay. Did I give you this question too? I think I did. Okay, I gave you this question, but I didn't give you. I didn't give you this question. I didn't give you, so don't worry. After giving you the 1,005 question, the next one is this. This is the next one. So ignore this one. This was a type. Okay. So here's it. You will deposit 1,000 at the start of each year. What is the future value of this annuity? How do you calculate it? It's fairly simple. Why? All you got to do is this time, instead of using, in fact, just copy the same thing here. Okay. Copy the same thing here. Drop it there. Change the begin to the end as always. And this time, instead of, remember, you're doing future value. So I can do FV. You can type FV here. And then make this FV. Okay. Future value. And then you are told that the interest rate is 8%. Okay, so change this 9% to 8%. It is annual, so you don't need to multiply, divide it by 12. And then you are told that it is 5 years. So check your years and make sure that it's 5 years. Don't multiply it by 12. The payment period that you are dealing with is 1,000. So change this one to 1,000. Remember, you are looking for the future value, not the present value. So you will not negate the payment. Okay? The payment is going to be positive. Okay? Because this is something that is coming to you. You're looking for that. Now, you go to the F vein. That is what you are calculating. So because you are calculating the F vein, the F vein cannot come here. So what can come here is what? Is a PV. So you got to know the PV rather. So you change this PV. And what is the PV? Well, right now the PV is 0. Okay. There's no particular PV value. What you are rather looking for is a future value of this annuity. But you have to now multiply this by 1 plus the interest rate, which is 0.08. You do that, and then you can find, instead of changing this, change this sentence to the future value of this annuity due, and change this to FV to represent the equation that you have already given here. And this will give you the future value. So you have to deposit 1,000 at the start of every year into this. The future value of this deposit is this. Okay. That is going to be 6,000. Sorry, I'm supposed to negate the payment because the payment is leaving. Okay, remember, you would deposit 1,000 at the beginning, so it's leaving you. So you calculate this and you get $6,335 at the end. Okay? At the end of the 5 years, the future income of this 1,000, this repeated 5 years 1,000, is going to be 6,335. So it's the same approach as the present value. The only difference is that you are changing all of these items. Okay. Any question on this? Any question? Who was able to do it, by the way? Seth. Are you the one who vanished, Seth? Linda.
Yes, sir.
What did you get? Did you follow? She
Yes,
said,
please.
she
I
said.
had 6,335.
The next time, tell us your answer.
Okay, Doc.
Okay, so start this, all of you. I want you to do this one here. Example 12 ABC. Let's say that, this is a question. You are saving 200 every month at the start of each month for 3 years into an account that pays 6% interest, compounded monthly. What is going to be the future value of this annuity due? Now, first of all, how did you know that it's an annuity due? You are saving 200 every month at the beginning. That's what to know that it is. So do that and let me know. If you're able to finish, just open your mouth and tell me your result. So that's it. I've done the first one for you. Let me show you. So as you can see, in this first one, you're calculating the future value. So you just write NPV. I'm just going straight away to show the answer for that. Okay, you're going to copy and edit it. The interest rate is 6. It is compounded monthly. So you divide the interest rate by 12, and then you multiply the period. The period is 3 years. So you multiply the period by 12. Okay. You are saving 200, so it's leaving you. So the payment is 200, negative 200. You're calculating for the future value. So the present value will be 0 as it stands now. This is going to be the ordinary annuity. Okay. This is going to be the ordinary annuity. Then if you want the annuity due, you multiply it by 1 plus the same discount rate that you have here. You do that. When you run this, you get 7,906. So if you do that 200 every month, okay, beginning each month for 3 years at an interest rate of 6% compounded monthly, you are going to get 7,906. People need to know this money to know whether they will be rich with it or not. I want you to find this next to. Whoever is done, let me know. When you're done, let me know. After this, should we continue the next one tomorrow? Or we should continue and go on and go on? What do you want? What do you want?
I think tomorrow will be, because we have been here since morning.
You've given you a top, so it's nice. All right. So finish these two. That means you got to prove to me that you got a right answer. If you don't get a right answer, you stay here. I've done the A for you. Do the B part and the C part and let me know your answer. If you look at it very carefully, the present value will not be zero.
Yeah,
Yes,
I made it. I made it
it's
5,000, but I didn't get the answer.
It's true. No, the present value is
The present value will not be
5,000.
zero.
It's 5,000. Yeah, I did it that way.
Present value is 5,000 and the savings is 1,000.
It's
Yeah.
1,000. Okay.
So that's about 33 million.
No.
Sorry, 3 million.
It's
It's
not
3
33
million.
million. Remember the
No, it's
interest rate and remember the compounding. Remember the interest rate is 12%, and that 12% is compounded monthly.
Yes.
So I think it's 33 million.
No, it's 3 million, not 33.
It's 3 million what?
3,348,368.
Yeah, 3 million. 3 million. 3 million.
Yeah, but saying 3 million alone is not enough. 3 million what? 3 point what million?
3.3 million.
3.3 million.
That is wrong.
Ghana cedis.
That is wrong.
Wow.
You are close there, but you have not done something.
So you said the rate is 12%.
Yeah.
And it's been compounded also monthly.
Yes.
So what are we not doing?
Let's see what the rest are doing, unless they are not doing anything. This is your last one. So prove to me. What did you do? What did you do with the rate?
I divided it by 12.
So it is what by what?
12 by 12. 0.
What did he say?
0.1.
Repeat what you said. Your line went off.
Yeah, please. It's 0.12 by 12.
Okay. What about the number of periods? What was your number of periods?
30 by 12.
You see, that's what you 30 by or 30 times. Is it 30 by or 30 times?
Please. 30 by 12.
But he didn't say 30 times 12. He says 30 divided by 12. That's what he said.
So we need to rather divide it instead of multiply?
Oh, are you kidding me? Are you telling me that the number of period you divide?
No, we multiply. That's what we did.
Yes, you're supposed to multiply.
Yeah, that's what they say.
And then you said you got 3.7.
Yeah.
I'm getting 3.67.
Yes, now that is correct.
Where
It's not
from
3.3, it's not 3.7, it's 3.67. So the one who got 3.67, teach them.
Okay, so what I did simply is that, so from all what you've done would have been right. So the rate is 12% divided by 12, 0.12 divided by 12. The end per number of years will be 30 times 12, right? Now the PMT, which is the annuity, we are using an annuity of 1,000. So that's minus 1,000. But the PV the way you look at it is like from the question says that 5,000 now, then 1,000 every other month. So if you are doing annuity due, assume that you are paying 1,000 now. Okay, so that 5,000 takes 4,000 off. So that would be like a single value being paid. So PV will be 4,000. So that caters for 4,000 plus a monthly payment of 1,000, where PMT is 1,000, PV is 4,000. That will give you a 3.67. I don't know if it's clear.
No, but Godo,
No,
is the PV is still negative 5,000. It doesn't change.
the PV. Okay, I used minus 4,000.
Yeah. So how come you got the same answer?
But if you use minus 4,000,
Yeah.
Where I look at it is that
Those of you who
the
use
payment,
minus 5,000, what did you get? Unless you also got the others wrong.
so we got 37, 3.7.
No, take your time. Your PV was what?
The PV is 5,000.
Is it?
5,000.
Say
Negative
negative
5,000.
5,000. Stop saying 5,000.
Yes, sir. Negative 5,000.
The PMT.
The PMT is negative 1,000.
Then the NPR.
30 times 12.
And then rate.
0.12 over 12.
Okay. And then your this thing is NPF.FV. Is it .FV?
Yes, sir. NPF.FV. Yes, sir.
Okay. And your when is end?
Yes, sir.
You shouldn't. And you said you got what? 3.7
times 1 point. Or are we not supposed to add the discounting?
No, that's where you are wrong.
Oh, okay.
Do you know why?
Oh, 3 point. Okay. So why? That I was about to ask her. Why?
He's also asking me why. You don't know why you are not supposed to add that.
So is it because it's just for no? But say if it's for 1 year, that's when we are not supposed to add that.
If it is for what? You're looking at the future value.
Yeah.
After 30 years of saving. After 30 years of saving, the question I'm asking you is, are you calculating an annuity due? What is in the question that tells you that payment is beginning? Annuity due is beginning every month. Is there anything in the question that tells you that something is starting? This is an ordinary annuity. You see, because your mind has been annuity due, annuity due, annuity due, you thought that all the questions are annuity due. Now look at the previous question. Okay, if you look at the previous question was very clear. At the beginning of each month, you are putting that 200 down every month. Now this one, you have an additional monthly savings of 1,000. There was nothing that says at the beginning of every month. And so what you are calculating is not an annuity due, you are calculating an ordinary annuity. And that is why you are not supposed to do times 1 plus 0, anything that else that you had there. Because it's not an annuity due. In fact, this question, when we looked at it, I told you that the question is asking you that what is the future value of this annuity due? So you were so clear. And I said, wow, this person is telling you what you should do. But that is not what you are doing here. Abudu, this page is not for you. This page is not for you, Latifu. All right. So do you guys get it? Before we go to the last one. Do you get it why you don't multiply it by 1 plus the interest rate, the compounded interest rate?
Somehow say so it's only an annuity due that we would have to add the compound, that rate.
Correct.
So, do we assume that anytime it is not stated explicitly in the question,
Anytime
it is
it
always
is
annuity
stated
ordinary?
explicitly, then it is an ordinary annuity or immediate annuity.
Okay.
But if it is an annuity due, you'll be told specifically that it is happening at the beginning. Can we proceed? Opele. And remember, the monthly payment, okay, the regular payment is what we need to know whether it is having an end date or a beginning date. It's a regular payment. Remember, the whole principle of an annuity is regular payment, isn't a fixed payment, a series of payments. And it is that one that we need to know whether it is beginning, the payment is at the beginning of each period or is at the end of it. It's not the lump sum one. For example, you see this first question. This first question says you are saving 200 every month at the beginning. So remember, the 200 is happening every month. So it is a series. It is that series that we need to know whether it's at the beginning. Okay, now let's go back here. You would deposit 1,000 at the beginning. So the 1,000 that you are depositing, it is happening each year. It's at the beginning. Now you go to this one too. You will receive 1,005 per month at the beginning, each month. So guess what? Whatever is happening each period, and it is at the beginning, then you know that is an annuity due. Now, even if I said that you receive 1,005 each month at the beginning, and then you will also receive 50,000, like this question said, you will also receive, it says that okay, you will also receive, apart from what you are paying regularly, you will also receive something. That you will also receive something. That one doesn't carry the beginning or the end is not affecting that one, because that one is a one time. But the series of payment is the one we need to know whether it's happening at the beginning or it's happening at the end. So when it comes to this second question, okay, the future value after 30 years, saving 5,000, we're not told whether you are making that saving, this is a one time. So it's not a series of payment. Now, the one that is a series of payment is this one with an additional monthly saving of 1,000. This one is a series of payment, but we are not told that it's happening at the beginning. Of course, we are also not told it's happening at the end. And so we assume then automatically that it's happening at the end, because that's ordinary annuity. That is an annuity immediate. And one clue that will help you also to know that this is also at the end than at the beginning is, he says that after 30 years of that saving now, then you now have an additional kind of saving. So it's sort of at the end. That's a clue. That's why you do not multiply the second one. Now look at the last one. Let me see whether you crack this last one. Do this last one, and that's it for today. I know that whilst I was talking, some of you are trying that last one already, so you should know exactly. If you're able to crack that, let me know.
I'm getting 9,100.
Sorry?
I'm getting 9,100.
That's what you're getting for this question.
Yes, sir.
Try again. Yeah, but now you should know that you have been rushing sometimes. Think it all through.
$8,966.
Goodness me.
Doc, I had 9,100.68.
Ah, this is not good. This is not good. This is not good at all. Who else has something? Something better, closer to 10,000. It's a question. You remember I told you that your understanding of the question will make a whole difference. So it's not just calculating the things into Python and then because you know Python, then everything is sorted. It's your understanding. So I need one last answer, which is the best answer. Who's going to do that? What was your rate? Who can tell me? Yes, what was your rate?
Uh, 0.06.
And what did you do with that?
Divided by 4.
Okay. What was your NPER?
4 times 4.
Oh,
What's your PMT?
Minus 500.
Minus 500, yeah.
And your PV?
0.
Okay. The rest too. The rest of you, what was your PV?
0, sir.
Doc, 0.
9,100. 0.
Okay, let me see. Thank you, right. The PV is 0. Should be 9,100.677.
That was my first answer, sir.
I was trying to be sure whether you know what you're doing.
Yes, the first one is correct.
You don't 9,100.
So it's 9,100.
Yes, that's what I
Yes,
said.
sir. Dot 6776955.
Yes. We all know the dot. We all know the dot. Well done. So, ladies and gentlemen, that brings us to the end of the entire caboodle for today.